To understand the concept of the sufficient statistic, we take an example so that you can easily understand the concept of sufficient statistic. That is example. Let y1 less than y2 up to less than yn denote the ordered statistic. So you can easily see that the random variables are expressed in terms of orders of a random sample of size n from the probability density function, that is e raised to power minus x minus theta, and its range from theta to infinity. Show that y1, which represent the minimum statistic, minimum of xi, is the sufficient statistic for theta. So in this case we have to represent that y, which represent the minimum distribution of the xi, is the sufficient statistic. So how we proceed for this one? As we know that our random variables y1, y2 up to yn are the ordered statistic. So the first of all we need to write down the distribution of minimum statistic, the PDF of y, which represent the minimum of xi, and we know that is g of y1, that is equal to n, that is the general form 1 minus f of y1 whole raised to power n minus 1 into f of y1. So we know that if we take first, we need to the value of capital F of y1, that is basically the distribution function. So that is from theta to y1 we are going to integrate it, our function, that is minus x plus theta dx, and that is straightforward integration. The net result will be, that is 1 minus e raised to power theta minus y1. Now we can put these results into the distribution of minimum statistic, which is in this case g of y1, that is n into 1 minus 1 plus e raised to power theta minus y1 into, that is e raised to power minus y1 plus theta, and when we solve this we will obtain that n into e raised to power minus n into y1 minus theta, and that ranges from theta less than y1 less than infinity. Now we are going to find the conditional distribution now, that is basically first we have the sample observations, that is x1 up to xn, given that y1 with respect to theta, and that is basically the giant distribution, can be represented at I varies from 1 to n, f of xi into theta over g of y1. इसमें जो g of y की इंटरेक्शन है, क्योंकि g of y दैट इज ए सब पार्ट ऑफ दिस, सो बेसिकली जब हम इसको लिखेंगे तो ये f of x i इंटू थीटा ही हमारे पास आएगा. जो इसका सब पार्ट है वो ऑलरेडी इसमें मर्ज हो जाएगा, और इसकी हमें इंटरेक्शन चाहिए, तो बेसिकली जो हमारे पास जो लार्ज पोर्शन होगा वही हमारे पास आ जाएगा. नाउ वी आर गोइंग टू पुट देयर रिस्पेक्टिव PDFs, that is e raised to power minus x1 minus theta and up to so on, that is e raised to power minus xn minus theta over n into e raised to power minus n y1 minus theta. तो जब आप इसको फर्दर सॉल्व करेंगे तो यू विल ऑब्टेन दैट इज़ बेसिकली मल्टीप्लिकेशन हो रही है ई की पावर में, तो ये पावर्स जो हैं वो जमा हो जाएंगी, दैट इज़ बेसिकली सम एक्स आई प्लस एन थीटा एंड डिवाइड बाय दैट इज़ n into e raised to power minus n y1 plus n theta. So where we know that y1 basically that is the minimum of xi. So that would be, ये हमारे पास n थीटा और n थीटा कैंसल आउट हो जाएंगे, तो जो हमारे पास रिजल्ट आ जाएगा दैट इज e रेज़ टू पावर माइनस सम xi over n into e raised to power minus y1. So you can see that in the resulting conditional distribution there is no theta which is independent of theta. So we can say that y1 is a sufficient statistic for theta, and that is what we want to prove. जो अभी हमने उसकी डेफिनेशन पढ़ी है उसी के मुताबिक बिल्कुल हम इसको लेके चले हैं. जो कंडीशनल डिस्ट्रीब्यूशन को जब हम लेंगे सैंपल गिवन दैट y, और जो हमारे पास रिजल्टिंग डिस्ट्रीब्यूशन होगा दैट इज़ फ्री फ्रॉम थीटा, एंड यू कैन सी दैट कि ये फ्री फ्रॉम थीटा है. सो वी कैन से दैट y1 इज ए सफिशिएंट स्टैटिस्टिक फॉर थीटा.